today we are going to be looking at the topic calculus. Now, under calculus, we have like two major subtopics, that's integration and differentiation, right? Differentiation and integration. You can also say differentiation is, differential calculus, and integration, integral calculus, right? Now let's see, we're going to start with differentiation, right? Under calculus, we'll be starting with differentiation. Now, calculus deals with change. It beats differentiation and integration. It just explains how two quantities change, with respect to one another. For example, now, okay, and in mathematics, the two quantities we have are majorly x and y, right? We usually deal with x and y, but if you have to apply it in real life, you'll be having other quantities. But now, since the world of mathematics, we're looking at x and y. For example, let's look at this. Let's look at this equation. Let's look at this equation. Y equal to 2x plus 1. Y equal to 2x plus 1. Let me draw the graph of this equation and see if I can use that to explain differentiation later. Alright, let's say we have 1 here, we have 2, we have 3, we have 4. Okay? Then on the y, this is the y-axis, right? This is the x-axis. Then on the y-axis, we have 1, 2, 3, 4, 5, 6, 7. Right? 3, 4, 5, 6, 7. Now, if I'm to plot the graph of this equation, this is what's going to happen. I'm going to start with, let's say, when the value of x, this is the x-axis, when the value of x is 1, this is 1, what will be the value of y, right? And this is how I'm going to get that. When the value of this x is 1, what will be the value of y? Y is equal to 2x plus 1, right? So let's see what the value of y will be. 2 times 1, that's 2, plus this one here, that's 3, right? So when x is 1, y is 3. So you're going to trace this 1 to this 3, where they intersect, that will be your first point. That will be your first point of the graph, right? Now let's try this same equation, but this time around with the value of x being 2, right? When x is 2 now, what will y be? 2 times 2, that's 4, plus 1, right? That's 5. So when x is 2, y is 5. You understand? When this x-axis is at 2, y is going to be at 5. This is where they intersect. Okay, lastly, let's just take 3 as the last value for x. Now when x is 3, what will be the value of y? 3 times 2, that's 6, plus this one here, that's 7, right? So when x is 3, y is 7. So join this to a straight line. Don't mind my graph, it's not perfect, but let me see if I can use it to explain the point. Now, you discover that when x was 1, right? When x was 1, the value for y was 3 when x was 1. Now, when x increased by just one value, that's from 1 to 2, you just added one value. Y added 2 values, right? That is it. Y now increased from 3 to 5. Why x just increased from 1 to 2? X increased by one value, while y increased by 2 values. That's this 5 because when we inserted the value for x as 2, right? Now when x increased by another one value again, that's from 2 to 3 now, y increased by another 2 values. You understand? So if you are being asked, what's the rate of change in y with respect to x? That is, how is y changing with respect to x? The answer to that question is 2, right? It's just 2. Like, y is increasing by 2 when x is increasing by 1. So the rate of change in y with respect to x is 2, right? Okay. Let's see if I can. Now, to answer that question without thinking too much or plotting this graph, this is what you do. If they ask you to find the rate of change in y with respect to x, they ask you to differentiate this equation. They ask you to find dy over dx, right? They ask you to find dy dx. They ask you to differentiate this function. They ask you to find change in y with respect to x, right? And this is going to be, let's differentiate this function. The power of x here happens to be 1. right? I'm going to multiply that power with this coefficient. That's 1 times 2. 1 times 2, that's 2, right? Then I'm going to reduce this power of 1 by 1 again, as I'm going to subtract 1 from the power. If the power was 5, I would have subtracted 1 and have the power of 4 left. If the power was 3, I will subtract 1 and have the power of 2 left. But now that the power is 1 here, I'm going to still subtract 1 and I'll be left with 0, right? No 1 minus 1, that's 0, right? So the power of x now happens to be 0. And you know from indices, any term raised by 0, any number, any letter, any value raised by 0 is going to be equal to 1. So this x raised by 0 now happens to be 1, and 2 times 1. And we have 1 here to also differentiate. I've differentiated this first term, I also have to differentiate the second term. Now, take note that the differential of any constant, that's any number without a variable like x attached to it, right? That's a constant. The differential of any constant is 0, right? If they ask you what's the differential of 6, is 0. What's the differential of 94? Is 0. You know what a constant is? A number without a variable attached to it. Like this one here is a constant. So its differential is going to be 0. Now, 2 plus 0, that's 2, right? So my change in y with respect to x is 2. So what I'm trying to do here is to explain what differentiation is all about, what calculus is all about, right? It's just that we have two quantities change with respect to each other. Now since this is x and y, right? X and y. I'm finding dy dx, that's the change in y with respect to x. I'm looking at how these two quantities change, right? So I believe that has explained differentiation to you guys. So let's just go into the main differentiation. Now, if you're asked to differentiate a function, this is what they're asking you to find. They're asking you to either find the y, the x, or they're asking you to find change in y over change in x. They all mean the same thing. Or they're asking you to find f prime of x. Now, all these three terms here, these three expressions here, they all mean the same thing, right? Differentiation. So let me give you the general formula, the general form of differentiation. If I have a function y equal to ax raised to power n, I have this function now, y equals to ax raised to power n, and I'm asked to differentiate this function. This is what I'm doing, this is what I'm going to do. I'm going to say dy, that's change in y with respect to x, that's dy dx. I can call it this. I can also call it change in y by change in x. Right? I can call it any of these traits and they all mean the same thing. Alright? But let's make use of dy dx, which is very common. Alright, so now they're asking me to differentiate this function y equal to ax raised by n. This is the general method of differentiation. Right? They're going to multiply the power with the coefficient. This is n, right? The power now is n. They're going to multiply n with a. So this is going to be equal to, differential is going to be equal to a times n, which is the power, right? A times the power. Then you have x here as this x. And now after multiplying the power with the coefficient, that's a times n, we are going to then subtract 1 from the power like we did just now. Right? You must, that's just the step. You multiply the power with the coefficient, that's a times n, and then you reduce the power by 1. Get the point? Alright, so let's take examples. Let's take example. Differentiate the function y equal to 3x raised to power 5. Differentiate the function y equal to 3x raised to power 5. Now, to differentiate this function, you are finding dy dx, right? You're finding dy dx. Now, like I explained earlier, this is what you have to do to differentiate. You multiply the power with the coefficient. Now, the power is 5, right? And the coefficient is 3. So let's multiply 5 with 3. That's 5 times 3, 15, right? 5 times 3, 15. And then you reduce the power by 1. That is, you subtract 1 from this power. Remove 1 from the power. Now the power is 5. Right? If you subtract 1 from 5, you're going to have 4. So the differential of this function y equals to 3x raised to the power 5 is 15x raised to the power 4. You understand? Let's take more examples. So we have 3 more examples to look at under differentiation, right? And the first, okay, let's say differentiate the following functions. Look at the first function. The first function we have there is 2x raised to the power 4 plus 3x squared, right? The second function we have is 7x squared plus 4x, right? Then the third function we have 10x raised to the power 3 plus 12. And let's start differentiating these 3 functions. Now for the first one, we have that f of x, you know this is another way of expressing y. Instead of writing y, you can just write f of x, because you see this y is a function of x. That is, to get y, you have to operate with x. That's why we call it a function of x. Instead of calling it y, we can call it f of x. So the first function now is this 2x raised to the power 4 plus 3x squared, right? Now, if I'm to differentiate this function, this is what I will express the differential as. I'm going to call it differential. Instead of calling it dy dx, which you can actually call it, I just feel like calling it f prime of x. Right? Remember, I said that's one of the ways you can express differentiation, f prime of x, or dy dx, or changing y by changing x. And since this is f of x, I'm going to call it differential f prime of x, right? And now this will be equal to, you multiply the power with the coefficient and you reduce the power by 1, as easy as that. So let's multiply the power with the coefficient. 4 times 2, that's 8, right? Then the power of x is going to reduce from 4 to 3, right? 4 times 2, that's 8. 4 minus 1, that's 3. Let's also differentiate the second term. We multiply the power with the coefficient, that's 2 times 3, 6, right? And the power of x will also reduce by 1. So 2 minus 1 is going to be 1, which usually indicates, but the power of x then is 1. So this is the differential of this function. Let's differentiate the second function. Y equal to 7x squared plus 4x. Now, this function y equals 7x squared plus 4x is going to be differentiated as this dy dx. It's going to be differentiated as 2 times 7, that is 14. Then 2 minus 1, that is 1, right? So the power of x is now 1 plus, let's differentiate this term. And listen closely, the power of x here is 1, right? Like the power of x here is also 1. Though we don't usually indicate 1, the presence of 1. Okay, now that's 1 times 4 is 4, right? But that 1 minus 1 is 0. So there will be no x here. Since we have x raised by 0, right? 1 minus 1 is 0. So I'm not going to write x. The differential of 4x is going to just be 4. Differential of 4 is 4. Okay, let's go to the third function. As y equal to 10x raised by 3 plus 12. Y equals 10x plus 3. Okay, 10x raised by 3 plus 12. And let's differentiate this function. Dy dx is going to be equal to 3 times 10. That's 30, right? And it's going to be x raised by, if you reduce 3 by 1, it's going to be 2. So the power of x will reduce from 3 to 2. Plus, now this 12 is a constant. You know why I say it's a constant? Because there is no variable attached to it. It's just 12, right? So the differential of any constant is 0. The differential of any constant, just clear in mind. The differential of any constant is 0. The differential of 49, 0. The differential of 4 over 2, 0. The differential of half, 0, right? The differential of 12, 0. So at the end of the day, dy dx is just going to be equal to 30x squared, right? So ignore the 0. 30x squared, that's the differential. Alright, so I believe we are all also familiar with the basics of differentiation. Now we're going to look at some principles of differentiation. Principles like multiplication rule, that's product rule, division rule, and chain rule. Right, let's look at these three principles of differentiation. Alright, so let's look at some rules of differentiation, some basic rules of differentiation. Now we have three of them there. We have the first one being product rule, right? The second one, quotient rule, and chain rule. So we are going to start with product rule. Product rule. Let's start with product rule. Now if you have a function y equal to, now this function y is the product of two terms. Let's say u and v. You can see now y is the product of u and v, right? If we are looking at quotient rule, you have something like y equal to u over v, right? Now the function y will be the quotient of u and v, right? But now we are looking at product rule, y is the product of u and v. If you are asked to differentiate this kind of function that has a product of two terms, this is what you do. Dy dx is going to be equal to u dv, right, plus v du. What do I mean by u dv and v du? Now this is what I mean by that. Now, you see this u dv is the product of u, that is the term u, right, and the differential of v. As here now, you're going to multiply this u with the differential of v, right? As you differentiate the term v and multiply it with u, plus you multiply v now with the differential of u. So here we are differentiating u, then multiplying with v. But this side here, we are differentiating v and multiplying with u. Alright, I hope you get the point. Now let's take an example. Let's take an example on that product rule. Now if you have this function y equal to 2x, then in brackets, x raised to power 3 plus, let's say 4, right? And you're asked to differentiate this function. Now you can see that we have two terms here, this and this. Okay, let me close the brackets so we'll see the two terms we have, this and this. And these two terms are multiplying each other, right? There is no addition sign or subtraction sign in between. It's actually, this y here is actually the product of 2x and x raised to power 3 plus 4, right? So, to differentiate this function, we can decide to open these brackets, that's do the multiplication, then differentiate what we get. Or we can also as well decide to apply this product rule. So this is what we're going to do. We're going to apply product rule to this, get an answer, and then try the other method to see if we're correct. Use the other method to check if we're going to get the same thing. Alright, so dy dx is going to be this from the formula I gave to us, u dv. Okay, this is our u, right? And this is our v. See, we have y equal to u and v, right? Y equal to u and v. This is our u, this is our v. So when I say dy dx is equal to u, this is the u, right? 2x, then times this dot here means multiplication, right? 2x, that's the u, our u, right? Times dv, as we're going to differentiate v. This is differential of v, right? U times dv. So this is our u, right? U times dv. Let's differentiate v. I believe we all know how to differentiate terms like this. Now the coefficient of x raised to power 3 is 1, right? I believe you can see that. The coefficient of x raised to power 3 is 1. So if you multiply this 3 without 1, you're going to get 3, right? Then the power of x will reduce from 3 to 2. We say you subtract the power by 1. So the power will reduce from 3 to 2. And I also see that the differential of a constant, in this case the constant now we have 4. 4 appear here, so it's a constant. The differential of a constant like 4 is 0. So I don't need to include its differential. Just differentiate this number here, that's this term here, x raised to power 3, and you get 3x squared. And that's all. You have gotten your u dv, right? Remember, you don't differentiate u. You just keep the u there and multiply it with the differential of v, right? Now that's for u dv plus. Now let's get v du. This time around, you don't differentiate v, right? Instead, you multiply v with the differential of u. Here we didn't differentiate u, we just multiply v with the differential of v. Now we're not going to differentiate v, we multiply v with the differential of u. Alright, so what's our v? uv, right? uv. This is our v. We are not going to differentiate it this time around. So we're going to have x raised to 3 plus 4, right? We're not going to differentiate v. Rather, you multiply v with the differential of u. So what's the differential of u? We have 2x. What's the differential of u? You know the power of x now is 1, right? So 1 times 2 is going to be 2. Then 1 minus 1, you know the power of x is 1. Reduce that 1 by 1, it becomes 0. So there will be no x here, since the power of x is now 0. So the differential of u is just 2, right? Alright, let's look at what we did. Let us review what we did. We said when you have product of two terms, uv, the differential of that function is going to be u dv, right, plus v du. Now u, that's u, dv, that's the differential of v, plus v, that's just v, multiplying the differential of u, that's du, right? Alright, so now we have that we took this example, y equal to 2x multiplying x raised to 3 plus 4. Now this first term here is our u, and this second term is our v, right? So when we see u dv, that's u, 2x, right? So our u now is 2x, multiplying dv, that's the differential of v, and the differential of v was 3x squared, right? Plus v du, that is v, we don't differentiate v this time around, v times du, that's the differential of u, that's this u, right? We differentiated u and we got 2. So let's put everything together and see what we're going to get. dy dx will be equal to, now this is 2x times 3x squared. What's it going to give us? 2 times 3. 2 times 3, that will be 6, right? Then x raised to 1 times x raised to 2. That is the total of x raised to 3, right? 2 times 3, 6, x raised to 1 times x raised to 2, that's x raised to 3, as multiplications of indices. Now we have this plus sign here. Now let's open this bracket as well. Let's carry this multiplication. 2 times x raised to 3, that's 2x raised to 3, right? Now 2, okay, there's a plus sign here, right? Now 2 times 4, that is 8. So the differential of this function, y equals to 2x multiplying x raised to 3 plus 4, is this, 6x raised to 3 plus 2x raised to 3 plus 8. Okay, now I have 6x raised to 3 here, and I also have 2x raised to 3. I say that I put the x raised to 3's together. So finally, the y dx is going to be equal to, okay, 6, 7, 8, that is a total of 8x raised to 3 plus 8, right? 6x raised to 3 here, then 2x raised to 3 here, a total of 8x raised to 3, and plus this 8 we have here. Okay, now, like I said, we're going to test this answer. We're going to check if this answer is correct using, let me see, another method. Now, this is the question, right? This is the question. The function is y equal to 2x multiplying 3, okay, x raised to 3 plus 4. So this is what we're going to do to test this answer. This is our answer. This is what we're going to do. We're going to open this bracket first before we then differentiate. Okay, so let's open this bracket and see what we get. Y is going to be this 2x now. We're going to use this 2x to multiply x raised to 3, and we're going to use this 2x to multiply 4, right? So 2x times x raised to 3, that is 2x raised to 4, right? You know the coefficient of this x raised to 3 is 1, right? So 2 times that 1, we got 2. For x raised to 1 times x raised to 3, x raised to 1 times x raised to 3, x raised to 4, right? Okay, that's how we did for the first multiplication, as this and this, plus 2x times 4. 2x times 4, that's 8x, right? 4 times 2, that's just 8. So 2x times 4, that's 8x. Now that we've opened the bracket to get this function, y equals to this, let's just apply the basic rule of differentiation to see if we're going to get the same thing here. Now this is y, right? Let's get the y dx. As let's differentiate this. And this is going to be 4 times 2, that's 8. Then you reduce the power by 1, that's 3, right? 4 times 2, 8. You reduce the power by 1, 3. It's easier than that. Plus, the power of x here is 1, right? Power of x here, 1. 1 times 8, that's 8. Then you reduce the power by 1. 1 minus 1, that's 0. So there will be no x here. Since 1 minus 1 is 0, it's gone. So this is going to be the answer. Divide the x equal to 8, x raised by 3 plus 8. That's what we got here, 8. 8 x raised by 3 plus 8. Yes, yes. Some of us now are saying, bro, this method is long and difficult and confusing, but this one just took us 2 lines, 1, 2, and got to the answer. So why disturb yourself with this long method, right? Now there are some questions that cannot be answered with this method, like you won't even have the ability to open this bracket before differentiating. So you have to go straight to this method, use this method. There are some questions like that, right? But this, luckily for us, this question, this particular question now, we're able to, test it with this other shorter method, which does always work for you, right? So every time you see that method around. Alright, so let's take more examples on product rule, right? Now the first example we have is y being the product of 3x raised by 6 minus 10 and x raised by 4 plus 30. And the second example, y is the product of x plus 1 and x plus 2. Now, I think you can use the two methods that I showed us just now to differentiate any function. There is no case where you cannot use that multiplication short method I showed you. You can only use any two of them. But there's going to be some cases where carrying out that multiplication before differentiating is going to be, lengthy. It's going to make it longer than this method we feel is longer, right? So when you feel like the multiplication aspect is shorter, you can decide to use that method. When it's looking longer to you or bulky, you just use this product rule, right? So I think you can use both methods to answer any product rule question. So let's answer this first one here. The first function we have y is equal to 3x raised by 6 minus 10 x raised by 4 plus 30. Now, this is our u and this is our v, right? This is our u, this is our v. So we say dy dx is equal to u dv, right? Plus v du. That's you multiply u with the differential of v plus you multiply v with the differential of u. Alright, so let's get dy. Let's get dy dx. What's our u? 3x raised by 6 minus 10, right? That is our u. These are v, these are v. Our u is 3x raised by 6 minus 10. And what's going to be differential of v? Like, let's differentiate v and see what we get. Now this is v, right? If you differentiate this constant, it's 0. Like I said, differentiate any constant, you get 0. So let's look at this one here. The coefficient of x happens to be 1, right? Now 4 times 1, that is 4. And this will be x raised to the power 3. Since the power of x reduced by 1, right? 4 times 1 gave us 4, but 4 minus 1 is this 3 here, right? So this is u, and this is the differential of v. So you're going to add that as plus, you add that to v du as v now, like the differential of u. These are u, these are v, right? So what's v? V happens to be x raised by 4 plus 30, right? V, x raised by 4 plus 30, that's our v. Now what will be the differential of u? Now we're no longer differentiating this now, huh? We're differentiating u, right? You differentiate this 10, whether it's negative 10, since the constant, get 0. So let's look at the differential of this first term here in our u. This is 6, right? So 6 times 3. 6 times 3. 18. Then this will become x raised to the power 5. You just take that. If you still want to go further, you have minus the differential of 10, 0, which is very, very useless. The differential of any constant, 0. The differential of this 30 was 0, so it wasn't useful. Right? So we have gotten u dv, and we have gotten v du. So let's just open these brackets and finalize with our answer. So dy dx is going to be equal to open this bracket. This is what we do. Use this x, 4x raised per 3 to multiply these two terms, right? And also use this 18x raised per 5 to multiply these two terms. Alright, so 4 times 3, that's 12, right? 4 times 3, that's 12. Then x raised per 3 times x raised per 6, that's x raised per 9, right? Now this is going to be 4x raised per 3 now times 10, negative 10. We have used this to multiply this. Now we have to use this to multiply negative 10. That would be negative 40. And 4 times 10 is 40, right? X raised per 3. It remains x raised per 3 because there is no x here to increase the power of x, like we did for the first one. Alright, plus 18x raised to the power 5 times x raised per 4. That's 18 x raised per 9. Since 5 plus 4 give us 9, right? So the total power of x is going to be 9. Because 30 times 8. Alright, so 18 times 30, that's 540, right? 540, then x raised per 5. 18 x raised per 5 times x raised per 4, that's 18 x raised per 9. The coefficient of this is 1, right? So 18 times 1, 18. Then x raised per 5 times x raised per 4, x raised per 9. Then 18 times 30, 540, right? Then x raised per 5. Since there is no x here to multiply the other x with. So let's see what we can put together. What can we put together? At the other terms you can put together. Okay, this 12 x raised per 9, right? And this 18 x raised per 9. So we can put these two x raised per 9 together. This x raised per 3, this x raised per 5. We can't put them together, we'll just let them be. Alright, so dy dx is going to be equal to, now 12 x raised per 9 plus 18 x raised per 9 is going to be what? The total of 30, right? 30 x raised per 9. Right, so we have a total of 30 x raised per 9. Then, since this one has the higher power, that's x raised per 5, let it come first. It's going to be 540 x raised per 5. Before we then finally have negative 40 x raised per 3. Alright, so this is the differential of this function. Now let's differentiate the second function. Good. Alright, so let's differentiate the second function. X plus 1, x plus 2. Okay, y is the product of x plus 1 and x plus 2. So this is our u, this is our v, right? These are u, these are v. So if we are to find the y dx, that is, if we are to differentiate this function, it's going to be u dv plus v du. Alright? If we are to differentiate this function, it's going to be u dv plus v du. Right? So let's find dy dx. What's our u? X plus 1, right? X plus 1. And what's the differential of v? Let's differentiate v here, x plus 2. Now you know that the differential of these two is 0, so this is a constant, so that's gone. But what's the differential of x? The coefficient of x is 1, right? And the power of x is also 1. So let's differentiate this x. 1 times 1, that's 1, right? Then we have x raised by 1 minus 1, that's 0. So the x is gone. We are left with 1. So the differential of x is 1, right? Alright, this is our u, x plus 1. What's going to be our dv? And what's going to be the differential of v? We differentiate this x, we're going to get 1. The differential of 2 is 0, so we're going to ignore that 2. The power of x here is 1, the coefficient is 1, 1 times 1, 1, but 1 minus 1, 0, so x is gone, we're just left with 1, right? The differential of x is just 1. Now, plus, what's our v? That's v du now. What's our v? X plus 2, right? Our v is x plus 2. Now, what's going to be the differential of u? What's the differential of u? This u. It's also 1. You know, if you differentiate this x here, you're going to get 1, like we got for this other differential. We also got 1 there. And if you differentiate this constant, this number here without x, you're going to get 0. So we're also going to ignore that part. Just differentiate this x and you get 1. So this is going to be our answer. But let's put the terms together. Let's open brackets and put the terms together. Alright, so 1 times x is x, right? 1 times 1, 1. Plus 1 times x, x. 1 times 2, 2. Alright? We've opened the brackets with 1. X plus 1 times 1 is x plus 1. X plus 1 times, x plus 2 times 1. X plus 2. So let's see what we can put together. Let's see the terms we can put together. And this is x, this is x. This is x plus x. That is a total of 2x, right? X plus x, that's 2x. Then we have 1 plus 2, that's 3, right? So the differential of this function is going to be 2x plus 3. Alright, before we end this video, I'm going to give you guys something to try out, right? Now we have this function. You're going to differentiate this function. Differentiate y equal to 3x squared plus 2x raised to power 2. Right? You're going to differentiate y equal to 3x squared plus 2x raised to power 2. Now you're also going to drop your answer in the comment section. Those of you who are going to attempt it, drop it in the comment section. Now, before we end this video, let me give you a hint on what you're actually going to do. Now, you're to apply product rule here. How are you going to apply product rule? You see this y is equal to 3x squared plus 2x times 3x squared plus 2x. Right? You know, when you see square, you're saying a number or a term, whatever, you multiply itself with itself. That's what you mean by square. You multiply in those two places. So that's in these two places we have 3x squared plus 2x multiplying. Okay, since we have square here, we're going to have 3x squared plus 2x multiplying itself again, 3x squared plus 2x, right? So now this is going to be your u and this is going to be your v. I believe you can take this from here, differentiate this function and drop your answer in the comment section. Now for those of you who haven't subscribed yet, do well to subscribe, alright? Do well to subscribe, turn on the notification bell so you're going to get the notification whenever we drop a new video. You're going to be aware whenever we drop a new video, right? Also share this video, you know someone out there writing JAM this year, writing YA this year, writing whatever examination. Just share the video so they get to them and they get to them maths, alright? Bye out.